We've touched so far a bunch of different types of control statements. We've looked at while loops, we've looked at for loops, we've looked at if-else constructs. In your problem set, you looked at switch statements. The big idea today is that we can put these control statements inside one another. We can nest them. So we're going to look at a couple of examples today, and hopefully they'll be somewhat illuminating. Here's a first example. Purpose of this little chunk of code is just to print all the proper divisors of a number. So that means if the number is 12, the proper divisors of that number are the factors of it other than 1 and the number itself. So for 12, it would be 2, 3, 4, and 6. Those are the factors of 12, other than 12 and 1 themselves. So we start by asking the user to enter what positive integer we want to work with. Then we say, okay, let's set the limit that we'll stop looking at. So that just means if we're looking for all the proper divisors of, say, 12, we would start looking at 2, and we would check, okay, is 2 a proper divisor of 12? Is 3 a proper divisor of 12? Is 4 a proper divisor of 12? All the way until we get to n over 2, which in this case would be 6. And once we've reached 6, we know, okay, we've checked all the numbers we needed to check. So that's exactly what's happening here. We start our counter variable at 2, d equals 2, and we're checking every number between d, or 2, and the limit, which is n over 2. Okay. Every time we'll enter the for loop, and you can see we have another if statement, another control statement embedded in here. Okay, this if statement is nested inside the for loop. If n mod d equals 0, so in other words, if n divided by d has no remainder, which is really just our definition of whether or not d is a proper divisor of n. Okay, so if it is, we want to print out that number and a space. Okay, so that's going to give us all the proper divisors of n. It's going to print them out one by one. Let's take it a little further. This is another example. It's based on the last one. Here we want to determine whether a particular number is prime. Now there are faster ways to do this. There are more computationally efficient ways to figure this out. But ultimately, one way we can do it is just by counting the number of proper divisors. And if there are no proper divisors for a particular number, then we know that number is prime. If there are more than 0 proper divisors, then we know the number is definitely not prime. So we start here. Again, we prompt the user for input. This time we add a counter. Okay, so this counter will start at 0. Our limit is still half of n. So that's where we're going to stop looking. Start our counter at 2. We're going to count all the way up to the limit. And if n is divisible by d, okay, this time we're not going to print the variable out. We're not going to print that proper divisor out. We're going to add 1 to the counter so that at the end, when we exit the loop, in other words, when d has exceeded the limit, so if n were 12, if 12 is the number we care about, that means once d has reached 7, we exit the loop, and we immediately check to see whether count, the number of proper divisors, was equal to 0 or not. If it wasn't equal to 0, then we know it wasn't prime, because there were some proper divisors. If it was equal to 0, then we know the number's prime, because it wasn't divisible by anything other than 1 and itself. So here, again, we have a for loop with an if statement nested inside. Okay, now there are going to be a lot of situations where we would want to exit a loop before the condition that's guarding the loop actually evaluates to false. So in other words, we'd want to be able to exit a loop early. And the way we do that is with a break statement. Okay, so here, this example is essentially the same code as the last one, but we break out of the loop early, and that allows us to pick up some efficiency gains. Okay, so there are a couple things we change here. First thing is, instead of cutting off our search for a proper divisor at n divided by 2. So for instance, instead of stopping looking for a divisor at 6, we know that we can actually stop looking for a divisor at the square root of n. So that's our new limit. That lets us look at fewer numbers. So right off the bat, we're cutting off some executions of our loop. But the main point of this slide is to take a look at what happens next. We first declare a counter variable, a control variable outside of the for loop. Now that's important because that means that because this is declared outside of the for loop, it means that we can change its value in the for loop, but after we exit the for loop, it will still be visible to us. It'll still exist. So let's take a look. Again, we start that counter at 2. 2 is going to be the smallest value we look at. Then we check to see, okay, is d less than or equal to the limit we set? Again, we changed the limit, but that won't affect us so much right now. If the number we care about, if n is divisible by d in its current value, rather than printing out the proper divisors, rather than even keeping track of how many proper divisors there were, we can immediately break out of the loop. Okay, this break statement takes us out of this loop. even before this condition is false. It takes us out here. And then we can check to see, okay, did we break out early? That's essentially what this Boolean condition is saying. If d is less than or equal to the limit. If we broke out early, that means that we know the number we're looking at is not a prime number. If we didn't break out early, in other words, if we got to the point where this condition evaluated to false, that means that the number was prime. So the break statement, again, takes us out of a loop before even satisfying the requirements to break out of the loop. In other words, making this condition false. Now, that's really helpful to us. In this case, it's helpful for efficiency purposes because it means that we spare ourselves unnecessary runs of the loop. But you'll find it useful in a ton of other situations as well. Let's take a look at a couple of examples of for loops that print things. So here's an example of star printer 1. We're going to print a set of stars that will look like this, 5 rows of 10 stars each. Here we have some nested for loops. Okay, so we have one for loop inside another for loop. We have an outer for loop and an inner for loop. So we can see the outer for loop is going to run num rows times. I starts at 0. Condition is while I is less than num rows, and each time we're going to add 1 to I. So the outer for loop runs 5 times. The inner for loop runs each time the outer for loop runs. Okay, and how many times does it run? Well, it runs num stars per row. So that means 10 times. So in this case, we're going to go through this for loop 10 times for each time we print a particular row. So let's see. That means that essentially first we enter here with I equals 0, and then we go on to the inner for loop immediately. So we start j at 0. And while j is less than num stars per row, j plus plus. Well, num stars per row is 10, so we're going to print this one. Then we'll print this one when j is 1. Then we'll print this one when j is 2. Then we'll print this one when j is 3, and so on until j equals 9. And finally, when j is 10, we'll break out of this loop. We'll break out of the inner loop and go straight to this line that comes after the inner loop, but is still inside the outer loop. So after we've printed 10 stars, we'll print a new line, and then we reach the end of the outer loop, and we go back. We increment our counter, so now I, which was 0, is now 1. Is 1 less than 5? Is 1 less than num rows? Well, yes, it is. So we'll enter again, and we'll do this for loop again, printing the second row. Okay, once that's done, we'll print a new line. We'll go back to the top, increment our counter. Now I is 2. Is 2 less than num rows? Is 2 less than 5? It certainly is. So we'll go in and we'll do this inner for loop one more time, and we'll do that until we reach the end. Okay, let's take a look at star printer 2. Here, again, this is pretty similar to the last one. Start with num rows, number of stars per row. We'll print each row one at a time, and within each row, we'll print the stars, 10 stars per row. The one difference is that each time we reach the end of the inner for loop, we decrease the number of stars in that row. So the first time we run this, we're going to print 10 stars. But then after we finish this first inner loop the first time, we subtract 1, we'll go back, and the next time we enter the outer loop, which means also the next time we enter the inner loop again, num stars per row will be smaller. Now it'll be 9, and we'll print 9 stars per row. Okay, then once this has finished running, we'll decrease num stars per row again, and this time it's 8. We'll come back. While I is less than num rows, we'll enter one more time, and we'll do this until our outer counter has reached 5. We can take a look at star printer as well. It's the same code. We'll give it a quick run and see, yep, same thing happens. If we wanted to, we could actually even increase num rows and see some more. So let's increase it to 9, and we can see, yep, each time the num rows decreases. Quick look at star printer 3. Okay, a couple things are different here. First thing, instead of leaving num rows starting at 5, we've changed it to 10. Second thing is we have encased our num stars per row decrement line inside an if statement. So we're saying if I mod 2 is 0, then decrease the number of stars per row. In other words, if we're on an even numbered row, then that's the only situation in which we want to decrease the stars per row. You can see the output that we get reflects that. Okay, on row 0, we print 10 stars, and then because 0 is an even number, we go ahead and decrease by 1. We go ahead and decrement by 1. But on row 1, after we've printed those stars, we don't decrement because 1 mod 2 is not 0. So we go on and num stars per row stays the same. Okay, let's take a look at star printer 4. Okay, let's figure out what this will do. Num rows starts at 5. Okay, that's just like normal. And I starts at 0, and we're going until we satisfy num rows. Okay. Now, J, the counter in our inner loop, starts at num rows minus I. Okay, notice that's not 0. In the past, we've started all these counters at 0, but here we're actually starting at num rows minus I. In this case, that's 5 minus 0, which is just 5. So we're starting at j equals 5. Our condition is while j is greater than 0, so we'll keep entering this loop and printing stars if j is greater than 0. And every time we're going to decrement our counter. Okay, so pause, take a second, think about what this will output. You have this code, so you can also open it up in Eclipse and give it a quick run yourself. Okay, hopefully by now you have taken a second to try to figure out what this is going to output, and maybe you've even run the code. Real quick, we'll just step through it. When I starts at 0, j starts at 5. We'll print 1 star. We'll do it again. When j gets decremented to 4, we'll print another star. Do it again when j gets decremented to 3. And we'll do it again when j gets decremented to 2 and to 1. So in this first row, we've printed 5 stars. Okay, when we finish running through our inner loop for that first time, and we satisfy the condition and we exit, we'll print our new line, and we'll go back, increment I, and now I equals 1. Okay, well that means that when we re-enter our inner loop fresh for the second time, now we're here and we initialize j to num rows minus 1. That means 5 minus 1, or 4, and we count down to 0. So that means each of these times we're going to print a star. So in this second row, we print 4 stars. When I is 2, j gets initialized to 3, and we'll only print 3 stars as we count down to 0, and so on. Okay, so that's a look at what star printer 4 does. We can run it real quick in case you haven't already. Beautiful. Looks just like that. Okay, one more example. This is a program called String Printer. Okay, you can see we make a new scanner. We prompt the user for a lowercase number, and we want to ensure that it's lowercase, so we actually turn it into lowercase ourselves. So reader.nextLine dot to lowercase. Okay, that's a string method that we're using. Now we're going to iterate through each letter of the string. That's what this outer for loop does. We're starting I at 0, and we're going until we reach the length of the string. And we do a couple of things inside that loop for each character. First thing we do is we turn that particular letter, the letter at index I, into a character. We store it into a variable called current char. It's of type char. Okay, then we take that current character and we do something a little quirky with it. We mod it by 97. So first of all, why do we mod by 97? Well, we do that because every character maps to a particular numerical value, and 97 happens to be the value that maps to lowercase a. So if we mod the current character by 97, then we end up with a value of 0 for a, 1 for b, 2 for c, and so on. Then, if we want to number them not from 0 to 25, but from 1 to 26, we can just add 1. And we store that in an int variable called current char numeric. Okay, then I nest another for loop in here, and I say start j at 0, while j is less than current char numeric. So really what that means is it's the particular letter of the alphabet, the number that maps to it, then print that character. So this will actually print a particular character some number of times where that number maps to the letter's position in the alphabet. So it's going to print A 1 time. It's going to print B 2 times. It's going to print C 3 times. And it's going to print Z 26 times. Okay, in between each letter, it'll print a new line character. It's going to go through and do that for each character in the string. You can see this is what the output is going to look like. So if I enter, what the heck does this do? Well, it's going to print what the heck does this do? And the number of times that letter printed corresponds to that letter's position in the alphabet. So you can see W prints way more times than A. T prints way more times than D, and so on. Just a goofy little thing, but it's a nice little demonstration of how nested for loops can operate. Okay, one last thing for today. One other way we can use nested control statements is to watch for sentinel values that help us break out of a loop. So here's a quick example. We've got a scanner, and we want to prompt the user to enter either a positive number or -1 to quit. Okay, we'll take that positive number from them using our scanner object. If that number is -1, then we'll break out of the loop. Okay, -1 is the number that we're watching for because it's not one of our eligible inputs. Okay, we're only looking for positive inputs. So that's a good flag that we can use to exit out, for the user to tell us that they want to exit. So if they enter -1, then we'll break out. Otherwise, we'll add the number that they entered to our running sum, and we'll say that we collected another number where count is collecting the number of values that we've gotten from the user. And at the end, once the user has exited using the Sentinel by entering number 1, once we've broken out of that loop, we can say, okay, if count is equal to 0, then the list was empty. Otherwise, give us the average. So that's what inputting via a Sentinel and breaking out of an input loop via a Sentinel value looks like. Big idea for today is that control structures like if-else constructs, like while loops, like for loops, like switch statements can be nested inside another control statement. And if we're inside a loop, we can use the break statement to break out of there. Okay, we're going to get tons of practice writing these as well as tracing through these using pencil and paper or reading through code ourselves. And the last thing is making sure that you have an idea of how to use a Sentinel value, for instance, number 1, to determine when to exit a particular loop.